In 1955, CSIRAC was sent to Melbourne University.
I think there's something like 8 tonnes of equipment the computer adds up to. So, it's not an inconsiderable, thing. And to see the photos of CSIR MARK1 coming down to become CSIRAC in Melbourne on a lorry with just a tarpaulin draped over it, you can't imagine something like that being moved nowadays. It would be fair to say that Trevor Pearcey and a couple of the others in Sydney were very sad to see the computer be transferred to Melbourne.
The decision to give CSIRAC away was very traumatic for me.
So the Division of Radiophysics didn't quite know what to do with Trevor Pearcey at this point because he'd had spent so much time devoted to computing. So he, in fact, went to England again for a couple of years and worked on a computer there called WREDAC.
So the two main people involved in acquiring the computer at Melbourne are Tom Cherry as Professor of Mathematics and Les Martin, the Professor of Physics. And really with Tom Cherry doing all the organisation, all the negotiation and organising the funding and organising the staffing levels that will be necessary in order to acquire the computer and to operate it successfully. Frank Hurst had been appointed just very recently to the physics department as a physicist, and Cherry singled him out as somebody he thought could take on computing because Frank Hurst had done some other technical work in the first few months at the university. He admits he knew nothing about computing. And Cherry said to him, no, we need you to go up to Sydney and have a look and learn about how this computer works. And so Frank Hurst sort of quickly went to a popular science magazine. And so the first thing he learnt about computing was reading it from a popular science magazine.
And when it moved to Melbourne, its name was changed to CSIRAC, which is the Commonwealth Scientific and Industrial Research Automatic Computer, because it was an automatic computer. It wasn't a person sitting at a calculator.
Our current understanding is that when it arrived in Melbourne, because the computation laboratory was set up not just as a service department, but also to teach and research, it was possibly the second computer science department in the world.
It would be the first in Australia at a university. We believe there are people in physics and chemistry and mathematics who can use it. It will be used as a training device as well, so we can start to then build a broader understanding in electronic engineering and other areas in terms of this new field of computation, and it will bring prestige to the university.
The chief of Math Stats, Alf Cornish, persuaded Trevor to come back from England.
But when he came back to Australia, he did continue working for what was now CSIRAC and developing their computing facilities.
In Sydney was an experimental computer.
Became a production machine during its later stages in the early 50s.
There was a real shift, I think, in the computer. When it was coming to Melbourne, it was moving into a completely different culture and was about how can we use this computer, stabilise it, turn it into a reliable computer. We don't care if it's not the fastest computer in the world. We want to get value out of it. We want to encourage as many disciplines and individual researchers to use it as possible. And so Frank Hurst really facilitated that process, coming into it fresh and coming in with a different kind of mindset, if you like, about how a computer could be used in a university.
Ron Bowles became responsible for the maintenance of the equipment, and he continued and was responsible also in the later stages after the machine had been transferred to Melbourne. He became an integral part of the Melbourne University's CSIRAC laboratory.
When it recommenced in operation in Melbourne, there were quite a few changes that had been anticipated earlier prior to the shift to Melbourne there. The input and output was improved.
I think it would have been very difficult if the computer had just arrived on the truck and there was nobody who knew how to run it in Melbourne to learn from scratch. So I think that transition of having Ron Bowles, having operated in Sydney and then coming down to Melbourne to become the engineer, and Frank Hurst and the operational computation side of things, having seen it operate up there and then be in Melbourne. And then very quickly, George Semke is appointed as an assistant to Ron Bowles. And so he then takes on a lot of the practical day-to-day operations of learning how to run the machine and keep it operational.
I got involved with CSIRAC in 1956 after I finished my diploma at RMIT. When I first joined what was then the School of Physics, the machine was already in Melbourne. It was in the process of being assembled. In the beginning, I helped with sort of interconnecting all the different parts of the machine, then helped with testing, and later on with running and redesigning certain parts of the machine.
Ultimately, found myself at the University of Melbourne, where my girlfriend at the time had got a job in the computation laboratory, where the fairly newly arrived computer from Sydney, CSIRAC, was then operating. This was wonderful for me because I'd been a radio ham and so on, and for the first time I saw this wonderful machine, probably the largest electronic machine in Australia, and I hung around and made myself useful and ultimately got the job as weekend service engineer.
Every morning, CSIRAC really ran for an hour. They had what they called engineering time for the computer. That was 1 hour in which they just fired the computer up, made sure it was operating appropriately, did some check programs on it, and literally it would take an hour or so for all the valves to become sufficiently stable and reliable, to make sure that the drum memory was working, to get the disk drum operating, had to be brought up to speed at a particular rate in order to ensure that you didn't lose bits of information. They actually had a screwdriver, would you believe, which they then applied to the drum, to the belt that drove the disc, so in order that it didn't come up to at 3,000 RPM speed too quickly. This was a machine that didn't just, you flick a switch and it turned on and it's ready to go. This is an hour to just get all the electromechanical, the electronic circuitry to be working in a sort of stable way before you would really want to start putting any kind of workable program through it.
In truth, I don't think I ever actually repaired the machine, but I could at least fire it up, test it, and call up the next person who was booked to come in and tell them it wasn't working.
And it was Yuri who is the one who keeps it running on a day-to-day basis.
One of the things that did happen was that the valves, the vacuum tubes, did break down quite regularly.
The number of valves in the machine was approximately 2,500, probably a similar number of diodes. If you believe what was written about valves in those days, there was no reason for it to have worked at all because you were sure to get some type of malfunction.
They had a dongo they would knock on the valves with just to check that the machine was operating.
Frank Hurst actually had a valve tester, which is a stick with a cork on the end. And when all else failed, he'd go around and tap them, because when you tapped them, they usually stopped going or went really wrong, and you could say, well, that was the thing that had to be replaced.
And CSIRAC would make a basic error roughly every half hour.
The main mercury delay line store was a little unreliable, and on occasions it could grow digits, and on other occasions it could lose digits.
Due to the unreliability of vacuum tubes at that stage, that we had a lot of problems, not only with the memory, with all the electronic circuits. Of course, filaments would burn out, be short circuits.
I remember ringing up Frank Hurst, who was the bloke in charge of the machine, in the weekend and saying, Frank, it's doing this, that and the other thing. Is there anything I can do about it? And Frank's not wanting to come in from his gardening and said, well, open the third door on the left and look at the fourth chassis down, and it might be one of the valves in there's a bit crook. Get the donger. So he had a rubber stopper on the end of a piece of stick, and he used to dong the valves, and look, when you donged that one, the whole machine would break down, which meant that was a crook valve and you replace that. So it was all sort of do-it-yourself fun in those days.
To get it to run for 4 hours straight, or even 2 hours straight, was a reasonable challenge.
You'd go in there and you'd always ask whoever you took over from, how's the machine tonight? Is it behaving itself? Is it reliable, or are you having trouble? And if it was a bit dicky, you had some really complicated thing to do, you might just pack up and go home.
Back in then, it wasn't very reliable at all. They'd often run programs 2 or 3 times to check that they got the same results from them.
Was that number of valves so that you would only be running for a short period of time and something would go wrong. However, it didn't turn out that way, surprisingly.
The assumption was that they had a mean time between failures of 1,000 hours, so the thing should have failed every half hour, but it didn't. And it could go a whole day or so.
You could peer into the memory and see dots corresponding to bits in the memory. And if something went wrong, you'd look in there and you'd see what's wrong. Oh, that instruction's grown a couple of bits. Oh dear, that's not very good. So that might have been a bit of outside interference or something. Sometimes when the temperature was wrong or the voltage was wrong, it tended to do that a bit more often. If you were stuck on something, the best thing you could ever do for yourself was to see if Ron Bowles happened to be looking over your shoulder, because he could fix it in 10 seconds flat. His favourite phrase was, "I don't know what you're trying to do, but you're in a loop here and you're not getting out of it because perhaps your test's wrong there. You should be testing this instead of that. There you are." And he'd walk away whistling. You're terrific. Ron was a tower of strength.
I believe the boot-up time of the machine took quite some time.
Each day, the first hour was taken up machine testing and warming up. Something is going to go wrong with a valve circuitry. It usually occurs at switch on or shortly after. So that period was designating as a test period, and also gave you a chance to do any modifications that you were thinking of or trying out any ideas that you had yourself. I think in the end, the off-air time was only about 10%.
It turned out, of course, that the best thing to do with these machines was never turn them off.
The heart of the machine was the basic clock. Having that in synchronism with the circulating pulses within the memory system there was perhaps the most important part. Perhaps if I had the chassis that I guarded most carefully, it would be the clock chassis, the one containing the basic clock, which was controlled by a mercury delay line in the memory box containing all the others. So as the temperature of the delay line memory fluctuated up and down, so the clock kept in synchronism with that fluctuation by changing its frequency so that the timing was always right.
I believe it was quite a noisy place to work, particularly when we got 5-hole paper tape and so on.
The Chief Maintenance Officer, Ron Bowles, had a good ear for the approach of an error. He could detect that the printer was going wrong even before the printer knew about it by the change in the sound of the printer.
Ron could hear that skip, miss a line or something, and get across to it, and it was quite a reasonable distance. He used to skid to get there in time to stop it because then you'd have paper tearing or something like that, and you'd have to start the job again.
Well, one night I was working away and tried to debug a program or something, and it was middle of the night, and miles from anywhere, just sort of peering into this thing and really preoccupied with what I was doing. All of a sudden, every bit on the screen suddenly lit up, which meant that the whole thing was destroyed. I looked up like this, and a beard walked around the corner, and his face came around the corner with this beard on it, and said, "That was a beauty, wasn't it?" They had a cyclotron in the next door room, and the bloody thing had arced over with, a couple of million volts or something, and that had caused me problems. CSIRAC was a teaching machine, and it was used by people for real work. CSIRO used it a lot, and of course the people at the university themselves.
It also provided a service to industry and trade and business. For example, it did building frame analysis for architects.
If you wanted to use CSIRAC, by and large, you came, you booked time, you taught yourself, or were taught how to program it, and you sat down and you drove the computer, stopping and starting it at the console.
And it was one person at a time, of course, and you were your own operator and programmer and everything else.
The meteorology department was looking for a master's candidate. I went along to be subjected to an interview by Dr. WREDAC, and I learned that the master's program was to use Australia's own computer, CSIRAC, to develop a numerical weather forecasting program called the Equivalent Barotropic Model. I was a science fiction fan, and the idea of using a giant brain was something I couldn't resist, and it was like being in a science fiction story, so I had to accept it, and so I went on to do my master's degree.
The Forestry Commission used it to calculate growth rates in plantations of trees based on the diameter and girth of samples.
Jeff Hill was the CSIRO officer seconded to the computation lab. He was the guru. He was one of the people that had come from radio physics with the machine. We went and visited him and asked him whether he could help us with our work, and he wrote the first program for us. Yeah, well, the first program I did was a modification of Jeff Hill's Fourier synthesis program. That calculation that took me 4 minutes on CSIRAC at that time was taking me 3 days with my hand methods. So it was 3 days to 4 minutes and down to blink of an eyelid these days. So it's incredible how much they help.
I was a user of CSIRAC from 1959 until its decommission in 1964. Primarily my purpose was in calculating the position of the sun and estimating solar radiation.
During the day, you could never get more than about quarter of an hour to go. That would be a big stint. Well, we were located out at Hyatt, so it didn't make any sense to get a quarter of an hour slot during the day. So we used to work at night. Quite often we'd go in shifts, 2 or 3 of us, and do different things and work all night.
The Army Signals used it to calculate radiation patterns of antenna.
It analysed X-ray crystallography.
So the machine was very heavily used. It really was a help for all sorts of people, did all sorts of different projects.
On open days, they developed games that people could play using the cathode ray screens, flashing lights.
There was one particular user of CSIRAC, Dick Jenssen, who was considerably interested in games and wrote a number of games for CSIRAC.
I started my master's degree in 1957. I was working on CSIRAC at the beginning of the year. I would have started writing very simple programs to play games probably within the first 6 months. I wrote games for CSIRAC because I'm a frivolous character at heart and I like playing games.
There was a game called The Way the Ball Bounces, and it was actually part of Dick Jenssen's project, and he invented this little thing which worked on the lights in the front of the computer.
The user flicked a switch on the console, on or off. The computer program remembered the previous switches. It then used the memory of those switches to determine what he'd thought the next number would be.
And you played it by guessing whether the light would go 2 steps forward or 1 step back.
If it was correct, it moved a dot on the front of CSIRAC to the left. If it was wrong, it moved it to the right. And if it moved it all the way to the left, on the cathode ray tube, it printed out, "I win."
And the person who consistently beat it was my first wife, Kay Thorne, who seemed to always be able to beat this by outfoxing it, and that just at the moment it thought that it had worked out the pattern.
It was very depressing because Kay Thorne beat the machine much more often than she should have.
He was trying to work out ways and bring in randomicities because some of those things were coming into the work.
So I rewrote the program to accelerate the movement of the dot on the front of CSIRAC. She still beat it more often than she should have.
Because he was trying to do weather prediction, long range.
Dick quite optimistically worked out a program to do weather forecasting on the machine, and actually he did get it working.
The forecast program that I wrote was essentially to see if forecasting with a computer was a viable concern. We broke the scheme up into 2 12-hour periods, and it took REDAC and I something like 8 months, I would say, to get 2 12-hour forecasts working. In other words, a 24-hour forecast working.
They had very early use of illustrations on the screen. There was work done in meteorology and trying to draw pressure patterns, and that's a very, very early example of computer art.
Who actually did the first, what I consider serious computer graphic, real computer graphic as opposed to a piece of entertainment.
One prediction that CSIRAC made showed that the system, which was a low-pressure system, essentially central illustrator, moved at the right speed in the right direction toward the east, and comparing it with actual observed weather pattern for the forecast day, we were very, very happy with the fact that it did produce the major features of the forecast. I believe that the barotropic forecast program was the 13th main project to be attempted on CSIRAC.
It did mortgage payments for the staff of the university.
The glaciological studies on CSIRAC were definitely used to determine past climate and to determine if the climate was changing currently and how it was changing currently.
At a later time, Jeff Hill's development of Interprogram in about 1960 brought the ability to do some programming in the English language.
We had developed interpretive systems while in Sydney, and in some early studies of what became called automatic programming, that the Interprogram system became eventually developed.
One can see that it's not very far from that to think, well, I wonder if I could write a program which, when somebody writes down what they want to do, it automatically calls up these subroutines. One can see in those subroutine libraries also the beginning of higher level languages.
When you programmed in Interprogram, you had an intermediate stage which translated the English language into a form that the computer could accept.
He essentially wrote a basic-like language, a high-level language that you could program CSIRAC with. So he had built an interpreter, developed a language and an interpreter. Quite an extraordinary man.
The manual's got an image of paper tape running down the side of the front cover, and anybody else would have picked a piece of paper tape out of the rubbish bin and copied that onto his manual, not Jeff. Because if you translate the codes on the side of the manual, it reads waffle for the front page of the Interprogram manual. So that's the sort of bloke he was.
Interprogram was some years ahead of BASIC, which was a worldwide, well-known English language type of programming.
You could prepare this on a Flexowriter offline, but it used paper tape, 5-track paper tape, as intermediate storage.
One would write one's program in the English language within the confines of what Interprogram could do, and then you would feed that program on 5-hole tape into the computer, and then the compiler would be read in on the 12-hole tape, and it would convert the English language into machine language, could be input directly to the computer. But I wouldn't be surprised if that Interprogram was certainly one of the first adaptations of English language to computing.
All you can say is that he must have been an extraordinary programmer to fit all that in. Of course, with modern computers, we've lost those skills. We don't try and use every bit of memory anymore. Now we just make it work. Use a high-level language. It takes another megabyte. Who cares? Back in those days, every bit of memory was accounted for.
But Jeff was a past master at it, and it was a great sadness that he died really at quite a young age.
Australia has a long history of music technology. From Percy Grainger back in the 30s talking about free music. Why can't music be free? Why can't we use any frequencies? And he was making music using analog electronic means.
Percy spent his life trying to build the ultimate music machine, and he had Wave creating things and so on. He was a very inventive person.
Music for multiple theremins. Percy Grainger was involved in that.
Perhaps the most famous of Australian composers.
When CSIRAC moved to Melbourne, Percy Grainger was there. And I said to Peter Thorne once, what a pity nobody introduced Percy Grainger to CSIRAC playing music. And he said, oh, we used to watch him walk past the computation laboratory. We'd say, there goes Percy Grainger.
On the walkway between us and the cyclotron, we'd see Percy in his tweed sort of suit.
And I just put my head in my hands. We were this close.
Little did he know that the elements of the ultimate flexible music machine were there alongside him, and we would never have thought about it, I suppose. He was a fairly strange character.
CSIRAC was used by engineers for entertainment, to play music for entertainment. It played standard popular tunes of the day. It was not used to say, what does it mean if we are to use a computer to compose music? What unique thing can we do with this that would expand our possibilities with music?
I'm sure he would have embraced it if he was alive today.
If somebody had opened the door, Mr. Grainger, please have a look at this machine. It plays music. What would you like us to do? There's a team of programmers here, and he would have had them doing all sorts of interesting things, and we would have had that beginning in Australia. As CSIRAC aged, they needed to find components to keep it going.
When it comes to getting parts for CSIRAC, there was a scavenging mentality.
Keeping CSIRAC running became something of a challenge.
Frank Hurst was a well-known scavenger.
Parts were found wherever they could find them.
When Frank Hurst was given the job of bringing it down from Sydney, they took him into the laboratory at radiophysics and said, take what you want. And Frank took everything. Old resistors and little neon display tubes and so on, and nuts and bolts. I don't think he took the blinds off the windows, but I think he took just about everything else. And so we had lots of spares from that point of view, and we could still buy vacuum tubes, of course.
I think it became pretty obvious in the early 60s that other computers were starting to appear around the place.
Remember, there were some people, including I think the head of IBM, that said, the world won't need any more than 4 or 5 computers. Total.
He was wrong, wasn't he? just underestimated.
I'm sure I've got about 5 at least.
It did not contribute to a homemade computer manufacturing industry. But what it did do was train the first generation of computer programmers. It made people aware of computers. So you could actually go to the university on an open day and see a computer.
Frank Hurst, who was the officer who bought it and later became the reader in charge, was an evangelist for the future of computers.
Frank did a tremendous amount of talking in public to unlikely groups about what computers would do for them.
I think he was invited to Sewage and Sanitary Engineers Conference, and he thought this is very nice. And then they suddenly said, and now Dr. Frank Hurst will now explain the use of computers in sanitary engineering. Frank got up and improvised on the spot. And on open days, the place was just full.
Most people in Melbourne hadn't seen one. They'd come up to an open day at the university and they'd see CSIRAC and they'd say to us, it doesn't answer questions.
People turned up with extraordinary questions, which they thought the electronic brain could answer. I mean, somebody rang Kay one night and wanted to know the name of an African shrub of 3 letters because it was in Wealth Words, which was a thing in the newspaper.
People telephoning and saying, I'm doing today's crossword. I need a flower that starts with V, 5 letters. Can you ask the brain for me? And things like that, because people didn't understand the limits of computation. It was called the electronic brain because it thought and therefore it must know everything.
Well, Frank Hurst used to take those calls usually because they'd go straight to the head of department. And he quite often hated to say no, the computer couldn't do that. So he used to give me the job of going over to the university library and finding out the answer.
I think it was thought of as an oracle by some people, yes, who used to ring in and perhaps annoy the staff with questions more appropriate to an oracle.
But the interesting thing, I think, is that now that's what most people use computers for. It's that sort of question.
When they finally switched CSIRAC off, it was described by one person as the sound of a dying animal.
Oh, it was a fairly sad moment, but then we were looking forward to a new machine. We already had a new machine, so things change, and I guess I was happy about that.
By the time CSIRAC went out in 1964, of course, there were many other computers around, and so the number of people interested in computing rapidly grew from sort of dozens to hundreds to thousands.
CSIRAC was intact and they knew how special it was when it was shut down. So it's the only surviving first generation computer in the world with all of its hardware intact and its software library and documentation.
I was actually the one that disconnected all the circuitry and helped to pack it up to go to the museum.
It then went into 20 years really of being locked away and not that accessible. First in the museum store, then for a while Trevor Pearcey, who was at Chisholm Institute of Technology in Caulfield in Melbourne, arranged for it to be on display there. It then came off display and went back into storage for another decade.
Trevor did quite a lot of work with CSIRO after CSIRAC. He initially suggested that they should have a network.
We had a very early network, a central computing facility. We were networking around Australia.
That was the beginning of CSIRONet.
He advised CSIRO on their CSIRONet, as did Jeff Hill.
He then went on also at that time to be involved in work at the University of Adelaide with Murray Allen, who was working on a computer called Cirrus.
Pearcey had some input into that. I think some of the simulations of it might have been done on CSIRAC.
And then eventually he did actually then go and work in the commercial area for CDC, and he went to the US for a couple of years.
I don't think anyone, except perhaps Masson Beard and Trevor Pearcey, may have had some inkling of the future of computers, but certainly I'm not sure many other people anticipated their growth.
The people at CSIRAC were pioneers in the foundation of the Victorian Computer Society and of the Australian Computer Society and of the Canberra Computer Society.
I think the legacy was in the people who had their first exposure of computers and the fact that a number of companies, for instance, could sample the benefits of computers.
I think CSIRAC remains an icon of computing for Australia, obviously, for the University of Melbourne, in particular, for CSIRO and its role in the establishment of computing in Australia, but I think internationally, to be the only really sole surviving intact first-generation computer makes it something that should be celebrated and cherished around the world.
I mean, the fifth stored program computer operational anywhere in the world. Here in Australia, for God's sake.
CSIRAC was undoubtedly useful. The work that I did with CSIRAC at the time couldn't have been done any other way.
I admired all of the early mathematicians, technicians, theoreticians who produced computers. I thought that what they were doing was changing the world.
The machine was well conceived and well engineered by Maston and the team at Radio Physics, which is probably one of the reasons why it's the survivor. It was the longest lived, I think, of the Gen 1 computers, and that was a credit to its original engineering and the capability of Yuri Simkiw and Ron Bowles in keeping it going.
Yes. I'm very pleased that its construction, even though it was a simple prototype machine, bore such fruit, became so utilised to the benefit of science.
It was used to its capacity and beyond.
There has been a sort of sense that CSIRO should have stayed doing computing.
Certainly Australia missed out by CSIRO having made the decision not to continue with development after CSIRAC.
We've had a lot of opportunities in a lot of ways and capitalised on very few.
I think Australia missed the boat in computing, at least on a number of occasions.
I think the people were there, the knowledge and the research ability to carry on was certainly available, but I don't know why the decision was made.
Who took it up? Where'd it go? Down the bit bucket. Gone.
I think that's part of the Australian story, isn't it? We invent well and implement badly.
My impression of CSIRAC is that it was a remarkable machine created and maintained by remarkable people who were extraordinarily inventive in solving their problems that they came up against, and resourceful with that. It was an extraordinary machine.
CSIRAC moved around a bit. Currently it's now down at the Science Museum in Williamstown, and I remember when there was an event down at Williamstown when it was transferred there, and had an opportunity to talk about Trevor Pearcey and what a significant role that he played, and it's wonderful that he's being remembered.
The Pearcey Foundation was formed by industry elders after Pearcey died, and it generally has the mission of promoting and celebrating our capability. Its awards are now recognised as the premier awards in Australia to remind people that we do have this capability and that we should be encouraging it and supporting it.